Hello everyone. I just watched my videos from the last ones I made. They're coming in real nice and clear on my TV and on my computer. Um, the ratio is still not as wide as the native resolution for the aspect ratio for YouTube, but I like where it's at, and I like how it shows only half the screen, and I can go over to the other side of my workspace and do things there. So this is how I'm going to keep it. I also notice I make them kind of lengthy like I'm doing now. I'm explaining a lot, so I'm just going to try to keep it as straightforward as I can. Please comment and let me know how I'm doing. So what we talked about last time, we're going to do equivalent resistance. So I'm going to call it this. I'm going to call this resistance dash REQ. And I don't know if you guys like the plain white space better or not. I have these grid lines, and again I have different lines to work off from. I don't know which ones you like better now, but I'm gonna go with none for now because I think that looks the best for me when I watch my videos that I've already uploaded. So I mean, if you have a different take on it, please just let me know and I'll change it. But resistance equivalence, I'm gonna pause this and I'm gonna draw a quick circuit, and then when I come back, to save time obviously, when I come back you'll see the circuit and I'll explain it. Okay, so this is the circuit I drew. I did it really quickly. I gotta change my color here. Right, it doesn't really matter which side is positive or negative. Usually the colored side, I think, it's positive and negative, but actually doesn't. I don't have a source in this. Ignore that. I'm stupid. But we'll call this right here. We'll call this R1, and we'll call the one below it R2, and we'll call the one far on the right R3. And what we want to find is we want to find the equivalent resistance between A and between B. And to do that, what we first have to do is look at the circuit and start from. We have to find a starting point, and it's hard to describe that starting point, but I would start from somewhere familiar and somewhere that you can start from. We can't start by finding equivalent resistance for this resistor and this resistor together and stuff. It won't ever work because, well, you can't do that. So what I'm going to start with is I'm going to make the connection that this resistance here and this resistance, even though it's two resistors, it still has one resistance if you put it on these black nodes here. And that resistance there, those two boxes sum together, box 1 plus box 2 is going to equal my REQ. And I can't add box 2 to box 1 yet because I don't know box 2's equivalent resistance. So now I know that's where I have to start. I have to start at box 2. Now, coming over here, looking at box 2, I'm going to redraw box 2. I'm going to redraw it bigger. Looking at box 2, we have a terminal coming in, and then it breaks off into a resistor, and then in parallel with that we have another resistor. Alright, and to find two resistors in parallel, remember that this is R1, this is R2. When two resistors are in parallel, there's that little shortcut that says you can take R1 and multiply it by R2 and divide it by R1 plus R2. However, I'm not going to do the short way. I'm just going to do it the normal long way so everyone can see. And our resistance equivalent for just this box is going to equal 1 divided by 1 over R1 plus 1 over R2. Okay? And again, that can be written as R1 to the negative 1 plus R2 to the negative 1, everything to the negative 1. Alright, so that's how we would find that. And then we would take that answer and we would just add it to R3 because they're in series. So let me give these resistor values, these resistors some values. I'm going to do this in green. Now I'm going to say R1 is going to equal 200 ohms. R2 is going to equal 250 ohms. And R3 is going to equal 1000 ohms. So there's an assumption I can make right now before figuring out what the first red box is, this one. I can make the assumption that no matter what, the total resistance of my circuit will not be less than 1000, because I know that 1000 is going to be added to or summed to this box here of resistance, or whatever that resistance is, and you can't have a negative resistance, so I know that it can't be lower than 1000. So when you find your REQ, if it's lower than 1000, that's very trivial to say to yourself that you don't have the correct answer, you need to recompute. So let me make this smaller, out of our way. Hope everyone can still see it. Put it up here. Well, I don't know what just happened, but smaller, out of our way, and let's compute this. So let's come back over here to this box. I don't know if you can see it. I know you couldn't see it before. I think I circled it. I don't know if you can see me circling it. So let's find the REQ. So let's find out the first box. What we're going to have is when we do this in blue, we're going to have R1, which is 200. That's going to be to the negative 1. Plus R2, which is 250, is going to be to the negative 1, and all that's going to be the negative 1. And it turns out that I get 100.111111, basically 0.1 repeating. So 100.1. And I know you can't see that all the way. And again, this whole thing that's highlighted right now, that I highlighted on accident, is this box right here. And that is 101.1. And now we have, I'm going to redraw this, because now I took those two resistors and I made one resistor. So I got one resistor now, and its value is 111.1. That's in series with another resistor, and its value is 1000. And we're measuring from here to here. Well, now to find the rest of the equivalents, we just have to add these together because they're in series. So you just add them together, and you'll get, due to some higher math, you'll get 1111.1, and don't forget to label your ohms, and that'll be your equivalent resistance. Okay? Now let's try the problem with some different resistor values. Let me erase all this shit. Whoops. Plug your ears. Different resistor values, and these resistor values will be again 200 for R1, and this time 10,000 for R2, and for R3 we'll just make it it doesn't even matter. R1 and R2 are the only ones I wanted to change so I could show you something. I'm at about 10 minutes now, so I do this real quick. I'm just going to find these two are in parallel together, which is, again, this red box right here that you can barely see. And R1 and R2, it would be 200 to negative 1 plus 10,000 to the negative 1, all to the negative 1, and let's just see our answer. I'm not even going to worry about R3 because of time. Let's just look at our answer. So I'm going to take 200 times 1000, this is the alternate equation for 2, divided by 10,200. I just added them together for the denominator. Alright, and I get something like 196.78. Now I want you to realize that even though this number is huge, it's at 10,000, it's a big number, it's considerably higher than 200, your equivalent resistance for the parallel circuit will not be higher than the lowest resistor in the parallel. So in our case, the lowest resistor is 200. We combined it with 1000 and we got 196, which is really close to 200. And if we did the same equation, 200 to the negative 1 plus infinity to the negative 1. So if we had a resistance that was so high it was infinity, all to the negative 1, our equivalent resistance would be 200. And that's because this is actually 1 over infinity. And as you know, 1 over a really large number like infinity will actually equal 0. Okay? Because it's such a small number, it's so close to 0, it can equal 0. So that just gives you an idea about that part of it. But again, equivalent resistance, the last video shows the format for adding series in parallel. This video shows an example. My next video will be starting with a little bit harder stuff maybe, or there might be a couple more other tasks I gotta take care of, but either way we're progressing very quickly. Rate, comment, subscribe. I don't care about your comments. If you wanna bash me, that's fine. I'll probably just be compliant and do whatever you tell me. So just be, criticize constructively so I know how to help you guys a little better.